If your NLB health checks are using the default settings, you're probably pulling healthy servers out of rotation way too fast and causing unnecessary downtime. I've seen this exact misconfiguration take down production apps 3 times this month alone.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm here with our resident cloud expert, and apparently we're about to learn why my health checks might be sabotaging my own infrastructure.
That's exactly right. Today we're diving deep into NLB target group health check configuration, specifically that failure threshold setting that most people never touch but absolutely should.
Okay, so I set up an NLB last week and I just left all the health check settings at their defaults. What's actually wrong with that?
Here's the problem, and it depends on which health check protocol you're using. For HTTP or HTTPS health checks, the default unhealthy threshold is 2 consecutive failed checks. For TCP health checks, it's 3. The default interval is 30 seconds either way. So if your application has a brief hiccup, maybe a garbage collection pause or a momentary CPU spike, your target gets yanked out of the pool in just 60 to 90 seconds depending on your setup. That's often way too aggressive.
Wait, so 2 or 3 failed checks and the server is just gone? That seems harsh.
It is harsh, and here's where it gets worse. NLB health checks are different from ALB health checks. NLB health checks originate from the NLB node IP addresses in the subnets where your load balancer is deployed. This is really important for security group configuration because you need to allow traffic from those NLB IP addresses or the subnet CIDR ranges. The checks verify TCP connectivity or HTTP response on whatever port you specify. If you're checking port 443 but your app needs a few seconds to respond under load, those checks fail even though your app is technically working.
So it's like a teacher marking you absent because you were 2 seconds late to class, even though you were literally walking through the door.
Perfect analogy, and technically accurate here. Here's something critical to understand about NLB. The health check timeout is fixed at 10 seconds and you cannot change it. This is different from ALB where you can configure the timeout. If your response takes 11 seconds, that's a failure, not a slow pass. The check doesn't wait around, and you can't make it wait longer.
Okay, so what should I actually change? Give me the specific settings.
First, increase your unhealthy threshold from the default to at least 3, sometimes 5 for latency-sensitive applications. In the AWS console, go to EC2, then Target Groups, select your group, scroll down to the Health Checks section in the Details pane, and click Edit. You'll see the unhealthy threshold field right there. Second, consider your interval. The default 30 seconds might be fine, but if you're seeing flapping, where targets go unhealthy then healthy repeatedly, increase it to 60 seconds or more.
What about the healthy threshold? Does that matter too?
Great question. The healthy threshold determines how many consecutive successful checks before a target rejoins the pool. Here's where it gets a bit nuanced. The default is 5 for TCP health checks, but 3 for HTTP or HTTPS health checks. So know which protocol you're using. Here's the key insight. You want your unhealthy threshold higher than your healthy threshold. Think about it. You want to be slow to remove targets but quick to add them back. A ratio of 5 unhealthy to 3 healthy means you're cautious about removal but responsive to recovery.
That makes sense. You're basically saying don't be trigger happy about kicking servers out, but once they're better, let them back in reasonably fast.
Exactly. Now here's a mistake I see constantly. People configure their health check path as just a simple endpoint that returns 200, but that endpoint doesn't actually verify the application is working. Your health check should hit an endpoint that confirms database connectivity, cache availability, whatever your app actually needs. In your code, create a dedicated health endpoint, something like /health/ready, that returns 200 only when all dependencies are confirmed.
Oh, so if my health check just hits the root path and gets a 200 from Ginks, but my actual application behind Ginks is crashed, the NLB thinks everything is fine.
Precisely. That's called a shallow health check, and it's dangerous. You want a deep health check that validates real functionality. But here's the trade-off. Deep health checks take longer to respond. And remember, with NLB you're stuck with that fixed 10-second timeout. So you need to optimize your health check endpoint to respond quickly. If your dependencies take too long to verify, you might need to consider using ALB instead, which has configurable timeouts ranging from 2 to 120 seconds.
Are there any other gotchas with NLB health checks specifically?
One big one. NLB health checks don't follow redirects. If your health check path returns a 301 or 302 redirect, that's counted as a failure, not a success. I've seen people accidentally configure their health check on HTTP port 80, but their app redirects to HTTPS, and suddenly all targets show unhealthy. Check your target group in the console, and if you see all targets as unhealthy but your app works fine in a browser, Redirects are usually the culprit. Also, keep in mind that health checks can fail for multiple reasons. The TCP connection can't be established within the timeout. The HTTP response code doesn't match what you've configured as healthy, or the HTTP response just doesn't arrive in time.
Let me make sure I've got this. Increase the unhealthy threshold to 3 or 5 so brief hiccups don't remove targets. Make sure my health check endpoint actually validates my app is working, not just that something responds. Remember the timeout is fixed at 10 seconds, so optimize your health endpoint to be fast. And watch out for redirects because NLB treats those as failures.
Perfect summary. One final pro tip: enable access logging on your NLB and monitor the healthy host count and unhealthy host count cloud watch metrics in the AWS/network ELB namespace. Set an alarm for when healthy host count drops below your minimum. That way you catch health check issues before they cascade into outages.
This is super practical. I'm literally going to go check my target group settings right after this.
That's exactly what I want to hear. That's it for today's episode. If this saved you from a future outage, hit that like button and subscribe for more cloud networking deep dives.
And share this with your team, especially whoever set up your load balancers. They might have the same default settings we just talked about.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.